Welcome back, Training Module 1.1, Supermini Introduction. So this is the video version of the live training that was presented in February. In case you missed it, we offer these videos for your convenience to review at a later date. This video will be two parts. So the first part will be an overview of the Supermini product, some of the value-added features, the competitors' success in the market, and the second part will be how to apply the Supermini product at the spindle. So if you look at the Supermini as an overview, there are several systems within the Supermini system. The 105, 109, 110, A105, and A110. So the 105 fits the smallest bore size. Let me pull my annotator out here. So the 105 fits bore sizes greater than 8 thousandths of an inch. The 109 fits bore sizes greater than 236 thousandths of an inch. And the 110 fits bore sizes greater than 236. And I will say on the 110, this is limited. Generally, a limited number of inserts that will fit 236. Generally, the systems are designed, 105 means one cutting edge, it fits in a 5mm minimum bore. 109 means 9mm bore and 10mm bore for the 110. There are several application options from boring to profiling, grooving, back turning, pre-part off, and chamfer tools, chamfering tools. You do also have with the 105 system some standard 105 face grooving inserts. And then the last two systems, the A105 and A110, you can see here, they are for face grooving. So that the holder is turned slightly 17 degrees to allow face grooving. We also have CBN, PCD, and CVD-D versions. So ultra hards for either hardened materials or non-ferrous alloys in the case of PCD and CVD-D. And then you also have full and partial profile threading. To connect the insert to the machine, you need a holder for that interface. We offer a lot of different types of holders. So some of the round holders that we offer are standard holders, adjustable length, collet holders, front clamping, coolant holders, double-ended, extended clamping, face grooving, BGT, and then also modular, high-precision modular systems like the WNF, WFB system. You also have square shank options, just standard square shanks, cranked square shanks, and then various options for Swiss machines like Tornos machines, Star machines. Also have combination holders. We have Groff adjustable holders with through coolant, VDI, polygonal, and WNF micro. So for the micro system, as well as the WNFB, the WFB system. Sorry, the WNF WFB system. The nomenclature is fairly straightforward. You have a right hand. If it has a U in the part number, that means it's designated as inch dimensions. You have the series, so this happens to be a 110 series. The width given here is in decimal inches, so that's 46 thousandths of an inch. And the L2 value is the reach length starting at 10 and increasing in 5mm intervals. So the way you handle that is you subtract whatever number this is, subtract 1, so that would be 4 times 5 is 20, and add 10. So that'd be a 30mm stick out. At the end here, you have the D-min, so that's the minimum bore diameter that this tool will fit in. For the metric side, much of the same. You have a handing, a right or a left hand, a series, a 110, a width is 2mm. You have a corner radius 2, an L2, same thing. This is 3, so you subtract 3 minus 1 is 2. 2 times 5 is 10, plus 10 is 20. So a 3 would be a 20mm reach length, and then the minimum bore at the end. So what's good about the Supermini system? The teardrop shape is kind of a pinnacle part of the system. It reduces deflection, simplifies setup. It reduces downtime because it's very easy to put in and out of the holder. There's no guesswork there. It only goes in one way. It resists torsion, and it's always on center. So versus a competitor where you have to align the set screw here and make sure you get that set screw tightened correctly in order for that cutting height to be on center. The HORN teardrop shape is always on center if the holder is set up correctly. So if you look at contact areas for competitor tools, if they're round, in theory, you really just have line contact in one place, and then the screw holding it in. With the teardrop shape from HORN, you have three. You have line contact on this wall, line contact on this wall, and then force applied on the top of the insert to hold the tool in. The F-center height and length are all held within 8/10. So the F being the center line dimension from the center of the tool to the tip, where it would relate to your bore if you had a boring tool. Also, a couple other features. The innovative clamping screw is really how this system works at its best. Provides rigid clamping. Again, the teardrop shape is rigid. It's a very rigid and large cross section for the tool, which resists torsion and enables precision coolant delivery on select blanks and gives you precision cutting height. If you look at the insides of the screw for the Supermini system, it's critical to repeatability and security of the process. It's a very simple but essential design. And basically, you know this needs to be replaced when you start getting a regular tool life or position of the cutting height. If this ball is extremely loose, if you can actually move it back where the flat is behind in this area, and then if you see any micro cracking on either end of the screw, it's a good idea to replace it. 90% of the time when there's a problem with the Supermini tool, if you change these screws out, it will solve the issue. So always keep those in good repair and replaced often. Supermini value-added features, a new system added, which we'll talk about in an upcoming training specifically, but I just wanted to briefly go over the Supermini HP. So the Supermini front clamping. So the Supermini front clamping is comprised of a holder that has a wedge clamp. Each blank size within the system, this is a 105 series, for instance. The 105 series has three different blank sizes. So you have a 5.9 blank, a 6.4 blank, and a 7.0 millimeter blank. So you have a clamp that corresponds to each of those blank sizes. When you buy one of these holders, it's going to come with one wedge, depending on how you specify which holder you pick. We recommend buying the other two wedges so you can hold the entire product line within the mini system appropriate for these holders. Additional sort of features, value-added features for the Supermini. Low torque requirements. You don't really need that much torque to lock these things down. The F dimension, as mentioned, is held very tightly, so that limits the amount of touch-offs you need to do. Often people back up just a little bit. They just swap up the tools. They back their offset off. They run a tool, resize, and they're good to go. No need to retouch this tool on a touch setter or a presetter. Length is held the same way because the back end of this is precision ground. So very, very convenient. Also through coolant through the back of the tool. If you look at competitors' tools, there's a lot of places for error. So this happens to be another variant within the horn system, the two screw holder, which has a little bit of an extended clamping length, which that's all detailed within the catalog and the technical documentation on which holders will fit which insert. For the most part, a 110 insert fits a 110 holder. The only thing you really have to worry about is that is the clamping length too long or not long enough for the holder that you're looking at. So a two insert or two screw holder tends to hold a longer blank. If you look at a competitor product, there's some complexities there. You have some of them have pins with a little dovetail. So if that angle's off, this could be off as far as positioning of the length. Then you have just standard set screw holding it in. Also, you have set screw with a flat. So some have a configuration that way where it's really dependent on how good the operator is at clamping those in the holder. If you look at the error that can generate the horn tool, if this angle is off a full degree, which they're held much tighter than a degree, it only means 1/2 change in the F dimension, or the dimension from the center line to the tip of the tool. Whereas the competitor product lines, if the pin is off, if this tool was bumped and this pin gets loose or misaligned, or the set screw's been worn out, or it's been sprung, the material sprung around the round part here, you can have translation errors and positioning of the cutting height. Same with the other holders, where you're relying just on the feel of each individual operator to tighten this. Sometimes the results can be fairly mixed. So looking at a couple market successes. So this is a 316 material, oil coolant, and the competitor was using 3,600 RPM, I believe around 220 surface feet, 3/10 per rev. Horn tool, we used an R105, AN25, 3,600 RPM and 3/10 per rev. The result, the competitor product was priced at about $17 on a contract price. The real price was about $24.50. The horn tool was $38. But if you look, the competitor got 250 parts per edge. The horn tool got 1,200 parts per edge. So that was a 212 cost per piece savings, which meant fewer tool changes and more uptime. Another example, this is on a Mazak Integrex titanium 6AL4V, just plain water soluble coolant. Tool type, boring, one cutting edge, 120 SFM. Feed is 1/1000 inch per rev. The horn tool used a 105 1823.2.5. In future trainings, we'll kind of break that part number down so it's a little easier to understand what those are. But EG35, which is a newer grade from Horn, it's a high PIMS aluminum titanium nitride. So the result, 120 SFM, we're able to feed at 1 thou and 5/10 per tooth. So the competitor product was, again, on a contract price was $22. The horn was $29.35. The parts per edge for the competitor was 35 parts, and parts per edge for horn was 213. So it actually resulted in a 450% cost per piece savings. The horn insert ran the entire job. And again, fewer tool changes, more uptime.